Hi there. In this video we're going to take a look at the AQA maths paper for Unit 1, November 2011, and it's the higher paper we're looking at. Okay, question 1. Olivia usually drives home from work and it says some of her journey times are shown. So we have a little table here that shows what time she leaves, what time she arrives, and how long it takes. And then it shows us week 2, and it says question 1A. On Friday of week 2, Olivia walked home. So on this day, she walks home. And it asks us to complete the scatter diagram for the 4 days that she drives home from week 2. Now, if you actually take a look at these points here, these 5 points are actually for week 1. That was a time of 30 minutes. And if you look back here for week 1, there she is on Friday taking 30 minutes to get home. And she left at 5:02. And you see that corresponds with the 5:02 here. So we're asked to complete the scatter diagram for these 4 days here. So let's plot our points. At week 2, she leaves Monday at 5:15. So at 5:15 she leaves, and it takes 34 minutes home to get home. So that point will go there. Tuesday she leaves at 5:18, which is here, and it takes 32 minutes to get home. So we'll plot a point right there. Wednesday, 5:20 she leaves and 37 minutes to get home. And Thursday she leaves at 5:07 and it takes 33 minutes to get home. So there we have it. Next part of the question, it says estimate the time Olivia would have arrived home on Friday of week 2 if she had driven. Use your scatter diagram to show how you decide. So what we're going to need here is a line of best fit. So we're going to need to draw a line in by eye so that the overall distance between the points and the line is roughly 0. So that would be a positive distance, that would be a positive distance, these would be negative distance. So the combined effect should be roughly 0. Let me just alter that a little bit. I think something like that will do the trick. You are given tolerance in the exam, so it doesn't need to be pinpoint accuracy. And we're asked to work out if she if she arrived home on Friday of week 2 if she had driven. So let's go back to our table. She left work at 5:10 on the Friday. So I need to check out where that would cross our line of best fit. So if we go up and across, I would estimate that that is roughly 32 minutes. So that will be 32 minutes to get home. Oops, let's change that. 32 minutes. And what time did she leave? She left at 5:10. So 5:10 plus 32 minutes, I reckon, is around 5:42 p.m. Moving swiftly on, it says Olivia wants to survey workmates about their journey times home. Write up a suitable question and a response. So fairly straightforward here. Suitable question: how long does it take you to get home? And a response: we want some sort of tick box so that we don't have any overlapping options. 0 to 15 minutes, 16 to 30, and so on. If you're unsure about this, do check out the video on questionnaires, and that will get you 3 marks. Next problem, Liz is buying a new car and selling her old car. So we've got 3 offers for the same model of new car, and we're asked to work out which one is best. So let's start with offer 1. We will pay 11,100 for the car, and if we trade in the old car we get 1/3 off. So I need to work out what 1/3 is of 11,000. So offer 1, I'm going to work out 1/3 of 11,100, which is 3,700, and if I take that away from the price of the new car, that will tell me the overall cost, and that works out to be 7,400. Let's have a look at offer 2. So it's 12,000 to buy the car, and we'll get 40% off. So I need to work out 40% of 12,000. I'm going to work out 10% first. 10% will give us 12,000. That means 40% is going to give us 48,000. So I'm going to take this 48,000 off the total price of the car, and that will give me 7,200. Let's take a look at offer 3. It's £294 a month for 3 years, and if we give in the old car, we get £3,375 cash back. So I'm going to work out how much she pays per year. So £294 multiplied by 12 will give me £3,528. How much will that cost for the 3 years? I'm going to times it by 3 to get £10,584. So she's also going to get £3,375 cash back. So let's work that out. We do 10,584, which is what she paid for the car, and we're going to take away the 3,375. That gives us £7,209. So which offer is best? Overall, offer 2 is the best, and that's for our final mark. Next question. We're given a list of numbers, and we're asked to find 3 numbers from the list with a range that's double the median. Now this question requires a bit of trial and error, and with a bit of thought you should work out that the 3 numbers we want are 5, 12 and 29. The range in this case is going to be 24 and the median will be 12. So the 3 numbers we wanted are 5, 12 and 24. Moving on. People in the town voted in an election. We're told that the probability of a vote was given for a particular party. We're told that one value is missing. We're asked to complete the table. Now, you should know that the total probability of this situation should add up to 1. So if I want to work out this missing probability here, I'm going to add all these up. So adding them all up, and then that gives me a total of 0.91. If I do 1 take away 0.91, that'll tell me what's left, which is 0.09. So that's who voted for the UKIP. Next question says the Labour vote to Liberal Democrat vote. We're asked to write that as a ratio. So if we look at the current probabilities, Labour is 0.24, Lib Dems are 0.22. So the current ratio would be 0.4 to 0.22. I'm going to multiply them by 100 to put them as integers, so it's 24 to 22, and then simplifying that ratio we get 12 to 11. Part 4C. There are 15,000 people in the town, 8,000 voted. How many people in the town did not vote Conservative? Well, let's think about this for a second. If only 8,000 voted, that means 7,000 didn't vote at all. But what about the 8,000 that did voted? If we go back to our table, we can see that 41% or 0.41 voted for Conservatives. So if we go back to the calculation and work out that 0.59 or 59% did not vote Conservative. So I need to work out what 59% is of 8,000 to see how many people that is. So I'm going to work out 1% by dividing by 100, and then I'm going to times that by 59 to get the 59%, and that gives us 4,720. And then finally add these two together, 7,000 plus the 4,720. That gives me a grand total of 11,720. Okay, question 5. 10 discs numbered 1 to 10 are in a bag. 2 discs are going to be taken out. And it tells us that the mean value of the remaining discs is 5. We've got to work out which two discs have been taken out. We're asked to work out one possible answer. So if the mean value of the discs remaining is 5 and there's 8 of them, well, let's work out the total value of the discs that are left, which is 8 times 5, which is 40. So the total value of all the discs left when 2 are taken out is 40. I now have to work out what was the total number in the bag before the 2 were taken out. So I'm going to add together 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And that gives me a total of 55. That's the value of each disc before we take anything out. So what was the difference? If I do 40 take away the 55, that will tell me that the value of the discs that were taken out were 15. So that means that if I choose any two discs that have a value of 15 together, we get the correct answer. So what could we choose? We could choose 5 and 10. We could also choose 6 and 9. Or we could choose 7 and 8. Any of those answers will give you full marks. As it says here, do be careful. It says one possible answer. I've shown you all the possible solutions. Okay, question 6. We're given a stem and leaf diagram and we're asked to draw a box plot to show this data. In order to draw a box plot, we need the median, we need the upper quartile, lower quartile, and also the max and min values. So let's work out the median really quickly. We've got 19 punnets. That means the median is going to be the 10th value. So let's check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's our median value. The lower quartile will be found by finding the median of everything to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we got 9 values. That means the median is at the 5th. And similarly, the median value up here will be the 5th. 1, 2, 3, 4, 5. So just confirming that. That's our median. That's our lower quartile. That's our upper quartile. If you're unsure about how to do this, do look at the video on stem and leaf diagrams. And then we finally have to draw the box plot. So I'm going to mark in the median, which is 26, which will be there. The lower quartile is 20, which is there. Upper quartile 32, there. Max and min, the minimum is 18, the maximum is 34, and we'll complete the box plot. You'll end up with something like that. The next part, it says data was also recorded for the number of raspberries in each of 19 punnets. We're given the median, we're given the interquartile range, and we're asked to compare. And like I said in the video on comparing distributions, what you want to do is comment on the median and comment on a range or interquartile range. So if the median of the strawberries was 26, we can say that on average, punnets of raspberries have more. And also I'm going to comment on the interquartile range. Well, the interquartile range for strawberries is going to be 32 take away 20. So 32 take away 20 is 12. The interquartile range for the raspberries is lower. That means they're more consistent or less varied. And there's your 3 marks. Okay, so it is estimated that there are this many grains of sand on the world's beaches. We're asked to write this number in standard form. Fairly trivial question. It's going to be 7.5 by 10 to the power of 18. Basically, the leading number must be between 1 and 10. Cannot be 10 though, so it has to be between 1 and 10. And it's going to be by 10 to some power. Originally, the decimal point was here, so the numbers are going to shift 18 places to the right. So I'm going to write that as 7.5 by 10 to the power of 18. This number is 10% higher than the previous estimate. Calculate the previous estimate. Well, that means that 110%, a reverse percentage question, must be equal to the 7.5 by 10 to the power of 18. So now I'm going to work out 1% by dividing all of this by 110. So we do 7.5 by 10 to the power of 18 on our calculator, divide that by 110, and that gives us 6.8181 by 10 to the power 16. So now I know 1%, I want to work out what 100% or the original amount was. So 100% is going to be 6.8181 by 10 to the 16. Multiply that by 100, which gives us 6.8181 by 10 to the power 18. And give your answer to two significant figures. Well, that will be 6.8 by 10 to the power 18. Moving on, it says some animals are twice as likely to have male babies as female babies. Explain why the probability of a male baby is 2/3. Well, if you think about it as a ratio, the ratio of males to females is going to be 2 to 1. So we would have 3 parts in total, and 2 of those parts are going to be male, so 2 out of 3. Next part, one of these animals is expecting 2 babies. Complete the diagram to show all possible outcomes. Um, if the probability of a male is 2/3, that means the probability of a female is going to be 1/3. And then for a second baby, this is going to be independent. The first baby and second baby are independent of each other. So this probability again is going to be 2/3. This will be 1/3, 2/3, and 1/3. And it's always nice when dealing with tree diagrams. I suggest you work out the final probabilities of, suppose, getting a male and a male by multiplying across the branches. So 2/3 by 2/3 will give us 4/9. Do the same here, males times females, so 2/3 by 1/3 gives us 2/9. 1/3 by 2/3 is also 2/9, and 1/3 by 1/3 is 1/9. This will help us now when we need to answer any questions. Such as this, a scientist wants to predict the likely outcomes for babies' genders. Which is more likely, 2 of the same gender or 1 of each? You must show your working. Well, 2 of the same gender is going to be this value or this. So I'm going to add these probabilities. So the probability of a male, male or female, female will give us 5/9. And also I'm going to have to work out the probability of 1 of each, which will come from these values. So that would be male and female, and then this one is female or male. So I'm going to add those two probabilities. Which one is more likely? Well, I think clearly you can see that it's more likely to have the same gender. Next question. The police want to know how many cars exceed the speed limit. An officer stands with a speed gun and records the speeds of 1,000 consecutive cars. Identify one possible source of bias in the experiment. There's a few things you could put here. What I have is the readings should be taken from different places. You could also say at different days or times. If you take 1,000 consecutive cars, it's not going to give you a good idea of what's going on, because at different places people may drive at different speeds. For example, on the motorway, people are probably more likely to speed than they are on small roads. So the more likely you are to get caught by the police as well, the less likely people are to speed. So lots of different things you could put down for that. This one here, we've got a group frequency table representing the speed of the 1,000 cars. We have to draw a frequency diagram. So the first thing we're going to need to do is just look at the class intervals here. We can see that they are different class intervals, so I'm going to need to complete a histogram. Now, to complete a histogram, we're going to have to add 2 columns. We need the class width and we need the frequency density. So that's it all worked out there. Now, if you're unsure where these values have come from, do look at the video I've done on drawing histograms. You do the frequency divided by the class width to get the frequency density. So I want to plot this. I'm going to need to put a scale here on the left side. So there's my scale, and then I'm going to start to draw the histogram. So I need a bar that goes between 18 and 20, and the frequency density is going to be 40. So between 18 and 20, I want my bar to go up as far as 40. Just a reminder, this is our frequency density on the y-axis. So I'm going to complete the histogram, um, and it will look something like this. So that's our final histogram after we've drawn in all the bars. Again, if you're not sure, do look at the video on drawing histograms. And the last question here, it says the speed limit for the road is 30 miles an hour. Two of the cars are chosen at random from the 1,000. Estimate the probability that both cars are at least 10% over the speed limit. Well, if the speed limit is 30 miles an hour, and we're interested in cars who are 10% over that speed limit, I need to work out what 10% of 30 is. 10% of 30 gives us 3, so the frequency of the cars above 33 is going to be given by this calculation here, 7 times 12. So just to show where that came from, if we go to our bar, I'm interested in the cars that are 33, going 33 and above. So I need to work out the area of this bar here. And again, if you're unsure how that's done, do look at the video on interpreting histograms. So what is the total frequency for that bar in there? It's going to be the area of the bar, which is 7 times by 12. So that's where this calculation has come from. So we got 84 cars we expect to be in there. What's the probability then? If I select one of those cars, it's going to be 84 out of the 1,000. So we're going to do 84 out of 1,000, and then I'm going to select a second car. So there's now only 83 cars left out of the 999 cars. Working that out on a calculator, we get 5,000 or 581 out of 83,250, and that's it. Hopefully you enjoyed the video. Best luck with the revision, and I will talk to you again sometime.